Hello, fellow Scratchers! Welcome back to the wonderful world of online multiplayer Scratch games. And I'm so excited because in this third episode in the series, all our hard work finally comes together. We'll be using clones to bring the Cloud players to life, and yes, supporting from 2 to over 100 players in-game at the same time. And those movement buffers from episode 2 will ensure everyone is moving as smooth and pixel-perfect as possible. What's this? You've gone blank. Are you still there? Now, I often get asked how we can know when players leave our Cloud games. Well, perhaps I just gave you a clue. Drop me a comment under the video if you think you know, and we can compare strategies as we cover this and much more in today's video. So let's open up our episode 2 projects, and before we begin to code, here's a really speedy recap of what we've done so far. In our player sprite, we moved the player around with the mouse, now recording their X and Y positions in the My Values list over a number of frames. While doing this, we broadcast Cloud tick. This is received in the Cloud player sprite, and then into the Send My Cloud data script. This code only runs once every 4th frame to ensure we don't exceed the Cloud sending limit. Now we encode our Cloud message, beginning with the player's unique ID, a large random number that only our player uses, followed by the rest of the data values from the My Values list of X and Y positions for the previous 4 frames of motion. And bam! We set the Cloud variable. These updates are also picked up by everyone playing our Scratch game. We are only checking the first Cloud variable, Cloud1, at present. We compare it to our stored copy to check if it has changed. If not, there's nothing more to do. But otherwise, we begin to decode it. The first number we read out is, of course, the sending player's unique ID. Now, of course, it's possible that we sent this message, so we ignore our own IDs right away. Then, either it's a new player, one with a UID not in our player list, in which case we add them to our list, or we saw them before, and either way, we ensure we also store the Cloud data against the correct row in the player list. That's our data dictionary. Splendid! Did all that make sense? I hope so. And this got us pretty far, but the next step is so much more exciting. We want to move from funky yet slightly boring Scratch lists to awesome and visually appealing Cloud player sprites all moving around on the screen together. Oh yes! Without further ado then, make sure to save the project as a new copy, for this is episode 3. Guys, let's get scratching! The first thing we want to do is make our Cloud players visible. We already have an item in our player UID list for every player that joins our game. The next step is to create a corresponding sprite clone for each player too. We already hid the original Cloud player sprite. For this, we'll act as a clone factory, creating visual clones, one for each player that is added to our player list. And so they remain identifiable, we'll give each clone a player item number, player hash, matching their list item number. As for the clone factory, we'll just keep their player hash blank. So, beginning in the Cloud player sprite, find the define process Cloud item script, and scroll down to where we just added a new player to the players list. And if we create a clone of this sprite immediately after setting the player hash, then the new clone will be created with its player hash already set to the appropriate new list item number. Excellent. Then right at the bottom, to keep our clone factory identifiable, we must set player hash back to the empty value now. This won't affect the clone we just created, only the clone factory. Okay, scroll over to the when I receive Cloud tick script. We now have a problem with this when I receive block. When we broadcast this message, not only will it run on this sprite, but also on every clone that we just created. So in effect, it can run many times per tick. We should guard against this. If player hash is greater than the empty value, that's true for any of the clones, then we'll want to do player clone stuff like moving around the screen. Make a new custom block for that, named player clone tick. And we'll let it run without screen refresh. Okay. And make use of it right away before stopping this script. The clones don't want to run any of the scripts below this. Only the single original clone factory sprite will go down that code path now. Perfecto! Let's take that define player clone tick script into some free space. Each player clone will run this script individually, and we want it to take the encoded cloud data and use it to move the sprite around the screen. As it happens, when we created this clone, we did so having just read the player UID out of their encoded string. Therefore, we can continue where we left off and read out the very next pair of X and Y position values. Read number from encoded string into the val variable, and then set X position to the new value val. Do the same again for the Y value, read number into val, and set Y position again to val. And I love that. It's so straightforward. And when we come around again after the next screen refresh, we'll read out the next pair of X and Y values, and that'll continue to play back the animation one frame at a time. But this encoded string is not boundless, only containing 4 pairs of data, so once we reach the end, we'll need to feed it more data to keep our player moving smoothly. And that is where our player data list comes in. With luck, while we were playing back the last animation from the buffer, the next movement buffer will have arrived over the cloud and have been popped into the corresponding player data list, ready for us to pick it up now. So, when we've reached the end of the encoded string, that's if encoded index is greater than the length of encoded string make a new custom block named getNextDataPacket, and we'll run without screen refresh. Okay, we'll code that up in a second. First, what happens when we get the next data packet, but we haven't received any more data yet over the cloud? If encoded string is equal to the empty value, in that case, there's nothing we can do except wait. So stop this script, and we'll try again the next game tick. Otherwise, off we go again. Right, get the next data packet. So we need to fetch it from the player data list. Set the encoded string to item of player data, and at item number given by our player hash variable. Cool, and I didn't mention this before, but since we don't want to ever read the same value out of this list again, we'll blank it out in the list using a replace item, player hash of player data, and stuff in the blank value. So the encoded string is set. We should also set encoded index to the number 2, ready to begin reading from the second character after that initial C that we joined on the front. Do you remember that? And the last step now, read in the first encoded number. That will be the sending player's unique ID. We can simply skip over that for now, as it gets us ready to read out the X and Y position values next. And then off we go again. The smooth playback can continue. It's a beautifully clean process, and I'm excited to test it out. Only hold on, I just remembered we haven't yet made our clones visible. So drop a show block here, triggering as soon as we've successfully read in the second packet of data. Okay, this is it. We need 2 windows side by side, and you'll notice the window I left open for testing on the right is still showing the old project. I need to reload that one. Hold on to your scratch cats, and here we go. Starting the right-hand project first. And there's my cat. And then the left window. Oh yes, are you seeing this? We finally have 2 cats visible in a single project at once. And as I move my cat around, look how smoothly the motion is playing back on screen too. Very cool. How about if we switch over to the second window? Oops, a little glitch there, but we are pushing Scratch's cloud servers pretty hard, and things are quickly back again. Pretty sweet, right? And I can switch back and forth without any issues whatsoever. Let's level this up. How about 3 players? Okay, not bad at all. The motion is still smooth, with a few glitches now and then, but don't forget, we are still running this on a single cloud variable. So what would this be like if we upgraded the project to use, say, 8 cloud variables at a time? Now that would be 8 times more bandwidth for the players to communicate over. Find the cloud setup script. This is where we record the original value of the first cloud variable. Let's duplicate that 8 times over, ready to support 8 cloud variables. Just make sure not to lose those 2 blocks off the bottom. Now, we already have a cloud2 variable left over from episode 1, so drop it in as the second item added to the list. Make cloud3 as a cloud variable. And then we do the same for cloud4, cloud5, 6, 7, and finally cloud8, all as cloud variables. Then, drag each one in to be added to the list, in the order 1 to 8. This ensures we know the starting value of each cloud variable. Next, we need to observe each cloud variable, watching for changes of value, and that's handled in our cloud tick script down here. Process cloud item 1, so again, duplicate that block 8 times over. And then we switch to use cloud variables 1, 2, 3, 4, 5, 6, 7, and 8. And then set the corresponding cloud item numbers down the left, again matching it in 1 through 8. Splendid! That handles the reading in of changes from all of our 8 cloud variables. But there's no point in doing any of this if we don't actually make use of these other variables. Look down here in the send my cloud data script. Yeah, we're only ever setting cloud 1, but we are faced with a choice. How do we pick which cloud variables to use now? Do we assign each player a random variable when we join the game? Or perhaps we switch every time we send a value? Or do we try to pick the least used cloud variable over time? Is that even possible? Man, well, that's some complicated stuff, but you don't have to worry, the simplest method is probably the best, and that is to switch every time. So make a new variable to keep track of our choice. Name it my channel, and keep it for all sprites. Then set it to a pick random from 1 to the length of cloud values. That should be 8 right now. Okay, move the set cloud 1 out of the way for now. We have 8 choices of variables to set. It may seem easiest to make 8 if blocks, and we could, but instead we're going to use the binary chop technique to only require 3 if checks by splitting the problem in half over and over again to reach a goal faster. If my channel is less than 5, that splits the 8 channels in half from 1 to 4 and 5 to 8. Then we can narrow it down further with another if my channel is less than 3. That splits the 1 to 4 as 1 to 2 and 3 to 4. One more time then, if my channel is less than 2. And hurrah, we have channel 1, so set cloud 1 to encoded string in here. Otherwise, it was channel 2, so set cloud 2 to encoded string. This pattern must continue. Duplicate the innermost if, and check if my channel is less than 4. If so, we set cloud 3 to encoded string, else set cloud 4. Now, the biggest duplication of all, the completed my channel is less than 3 script, down into the empty else branch, and we can now see a pattern. So simply set the right-hand cloud variables 5, 6, 7, and 8 in that order, and then we notice that these are both less than 7, 5 is less than 6, and for the other choice, 7 is less than 8. Job done. And with that, it's high time we gave it a test. We should make all our cloud variables visible so we can confirm they're all getting set. If any are not now changing value, then you'll have to go back and confirm that you got all those if conditions correct. Looking good here though. Every cloud variable has changed, so I am confident to progress on and test this across the cloud. Bring back the second window. I'm making sure, of course, that you saved the project and reloaded that second browser window. And now let's see what we've got. Okay, yes, it's looking pretty much the same, but that is a good thing. All we've done is make the engine 8 times more capable and stable. And that is a great thing if we are really wanting to support 20, 50, 100 players, right? Now, with 3 players again. And we already are able to observe the benefits of extra cloud bandwidth in the form of fewer dropouts and glitches. Yeah, this engine is really coming together now. So what else is left? The natural progression is to next talk about what happens when a player leaves the game. A player clicks the stop button or closes their browser window, and yet every other player continues to see the player 3 in their game, just no longer moving around. Not only that, but we are also no longer getting any cloud variable updates from that player. So how do we detect that they've left? How about this? We keep a record of how long it has been since each player sent us a cloud update, and after a short period without any contact, we can be pretty sure that they've left the game. How simple is that? This should be a cinch to code up. In the Cloud Player sprite, find the player clone tick script. Make a new variable named inactive for this sprite only, that's important, as each clone will need to keep track of their own inactivity. And then, every time we look for the new cloud data but don't find any, we change inactive by 1. With no activity, this will grow by 30 ticks every second. So if inactive is greater than 150, that will be 5 seconds, we want to remove them from this game. And you may find this a little surprising. We don't delete the clone, only hide them instead. And we scrub their unique ID out of the player list. The reason? Each clone has a player hash that matches their item number in the player list. If we were to delete an item, then that link gets all skewed and things will go very wrong. Disaster! So we don't do that. So just scrub out the player UID by replacing item player hash of player UID with the blank value, and hide this player clone. Out of sight, out of mind. Lastly, down here, when we do receive data from the player, we can set inactive back down to 0. This is now active. Perfect, it's testing time. Remember to save the project and reload the second window. The first test is to check that both our players are visible and not becoming inactive when they shouldn't. Check. Then I stop the right window. And this is the moment of truth. The second player is still visible in the top left corner of the window, and they are not. They have left the game. Haha, that is awesome. Take a look in the player UID list and confirm that their UID has been blanked out too. That worked a treat. But hold on, what happens if I restart player 2's project? The answer is the first player slot stays empty, and a brand new slot is added for the rejoining player. Now, I mean, that does work okay, but it's not very efficient, and we will hit problems after enough players leave and rejoin, eventually using up all 300 of the clones that we have at our disposal. So instead, how about we get players to reuse the expired empty slots as they join our game? Guys, let's get recycling! Find the process cloud item script and scroll down to where we are adding the new players, here. Instead of instantly adding new rows, let's check for those empty slots. Duplicate the set player hash block and drop it in before we add rows to the player list. But this time, we are looking for empty items in the list, the blank value. Then using an if-else, if player hash is again 0, then nope, there were no empty slots. So go ahead and add that new row after all. But if player hash is greater than 0, then we did find a free slot. So this time, don't create a new clone and simply replace player hash of, and not player data, but the player UIDs, and replace it with val, as that still holds the unique ID of the joining player at this point. And then the clone player should pick up the new data packet and spring back to life. Wunderbar! We have to test this right away. Save and reload the second window and smash those green flags. Straight away, I'll stop player 2's game and wait for them to leave. Yep, there they go. Now we have an empty game slot, so will it get reused when we rejoin? Yes, they do. That is so smart. clone recycling for the win! We can of course push this a little harder and try the same test with many more players at once. To make this more fun to watch, let's change the My Player script to cause the cat to dance in small circles. We only go to the mouse pointer when the mouse button is down. Then always move forward by 5 and turn clockwise by 10. This will take us in those small circles. Switch the direction mode to Don't Rotate, for the time being, as direction will be covered in the next episode. Finally, to distinguish our player from all the others, why not set their colour effect to 20. Nice! Okay, let's do this! Save and reload all the project windows. Yep, I'm using 4 now. And it's easy to see which player is mine on each screen, and the movement makes it more obvious which players are having network glitches. Pretty sweet so far. I'm enjoying their hypnotic dance. I'll stop one player, and they are removed from the other windows after 5 seconds. Then rejoining. Yeah, it's instant. And now the blank slot is recycled, so that is good. Next, I'm stopping all but one player, and there are 3 empty player slots. And as I rejoin, the player slots get refilled, and the gameplay resumes. That works great. So who's ready to begin plugging this into our own games? I know I am. And in the next video, I'll show you exactly how it's done. So please drop me a comment under this video to let me know what game types you'd like to see covered first. I'm planning to show it off in a platformer, a top-down game, maybe the Raycaster, and perhaps some kind of shooter game too. What do you guys suggest? Anyhow, we have reached the end of this episode. I do hope you're enjoying this series. If so, please do smash that like button. And if you haven't already, subscribe to the channel, ticking that bell icon so you get notified as soon as the next episode lands. But until then, thanks for watching, have a great week ahead, and scratch on, guys!